And we are live. Ed Bailey and Ahmad Carrick from Cribl. We are here today to talk about scaling Syslog. This is part of our endless, and we are going to keep talking about reference architectures for Cribl until, forever. It's just going to keep on going. Happy to be here. It's a great day in Atlanta. Ahmad, how are you doing?
Doing fantastic. We finally have the sun out here in San Diego after our infamous atmospheric rivers making their way through. So thank you.
That's crazy. Isn't there like a song about it never rains in Southern California?
Yeah, not so much this year. Not so much this year.
Yeah, someone told me there was snow outside of San Diego. That's just like what?
Yeah. I'm looking forward to seeing it. We're driving to Palm Springs here in a couple of days, and I'm looking forward to seeing the snow.
That's too crazy. Yeah, I'm on the East Coast, out in Atlanta, so it's lots of fun. It's a great weather. Spring is breaking out. There cannot be more pollen. It is unbelievable. So we're gathered here today. We are going to talk about scaling Syslog. Probably one of the most common issues we see with our customers. Everyone struggles with it for a variety of reasons. It's never going away, but we're here to help. Ahmad, can you tell me? So you deal with a lot of customers as a principal architect. What are you seeing out there?
Yeah, Syslog is probably one of our number one main protocols that we see customers using Cribl for. Syslog can be a pain in the ass. One, it comes in a wide variety of formats that every vendor has their own format for. And two, there's the whole TCP versus UDP to ship the Syslog data out through. And customers struggle to make the right choice over there. So we help them, we guide them a lot in which direction they should go, how they should be sending their Syslog, and then using Cribl to basically help route that data to process it and make better sense out of it, send it to a system of analytics separate from the system of retention. But yeah, it's definitely our number one. And it requires a lot of thought to get it correct, to get it right.
Right, and I'm gonna bring up some slides, some boring slides, but slides nonetheless. We talk about different use cases. We're going to give you some guidelines, some guardrails of where these different approaches make sense. Having a maximum full-scale solution for 20, 30 terabyte a day environment doesn't make sense for everyone. So we're going to talk about, depending on your levels, depending on the complexity of data, here's some things to think about. And please use your load balancers. So that's what you got to do. All right, here comes some slides. So talking about guidelines. So this is part of a reference architecture series, guidelines for scaling Syslog. We're going to talk about, part of the reference architecture, why is scaling Syslog such a pain, guidelines and guardrails. Talk about the differences between UDP and TCP Syslog and why you want to avoid one of those more than others. We're going to talk about the glory of load balancers and also the differences between a dedicated worker group and an all-in-one worker group, and also with major scale, the idea of creating a tiered solution, and then some closing thoughts. We're going to keep announcing our new reference architecture. Got a nice QR code to get you to the link. Really proud of what the team's done. I mean, I think it's a great way to help get our customers started down the right path faster. Ahmad had a huge role in making the reference architecture, and so gets lots of credit there.
And the idea here is that this is a starting point for getting you 75% of the way there, let's say, and that just having something solid to start with. That's what these reference architectures.
You're absolutely right. Everyone does things a little bit different, so we want to make sure you're having those guardrails of having two servers behind your load balancer, using load balancers, using pools, but you also have to then customize for your own particular needs. I was just working with a prospect earlier today who has 9 indexer clusters. So we had to come up with a way of how do we take in data through a series of worker groups and route the right data to the right indexer cluster. Everyone's a little bit different, but we're going to give you that framework to get you started. I've been there as a customer when you're just like, here's some software and good luck. And so we want to make sure that we are not doing that, because it's nothing more painful, because good engineers are going to figure it out, but you're spending so much time. I mean, FMFO, you're going to screw around and find out. And so that's it. You don't want to have to do that. We want to give you those answers earlier on, so you're getting value instead of messing around.
Exactly.
So let's say, what is Syslog and why do I care? Can you give me the lowdown?
So Syslog is probably the main protocol that all vendors out there, network and security devices, use to send security events, send network events, status events about what's happening on their devices, send them out to a destination, send them out so that they get consumed in a SIM, send them out so that they can get consumed in a log analytics tool. And they're very voluminous. And Syslog was originally designed as a protocol to be leveraged over UDP. And unlike protocols that are designed for TCP, those protocols like, say, HTTP, those will open new connections regularly, open new TCP connections regularly, and really take full advantage of the TCP stack. Whereas Syslog, again, it was designed for UDP, and if you enable it as a TCP-based protocol, data gets streamed over one long-lived connection. It doesn't establish new connections regularly like HTTP does. It will put it over one long-lived connection. And that causes challenges that there's considerations you have to take into account when you are using Syslog over TCP. So we'll talk a little bit more about that. But yeah, in a nutshell, it's the main protocol that network security vendors out there use to report what's happening on their devices.
So I have to share a little bit of my own my pandantic things that just make me crazy. Much of what you call Syslog isn't Syslog. Syslog has a set of very strict and well-defined RFCs that if vendors followed those RFCs, our lives would all be a little easier. More often than not so much.
And everybody follows the RFCs, right?
Oh yeah, everyone. Yeah, so let's put a JSON payload over UDP, and call it Syslog. Let's have a timestamp that's, inaccurate. Let's have timestamps that don't have the time zone. I mean, just those are all things that just, incredibly necessary data, but just things to think about, especially if you have a multinational infrastructure. And this is something we talk about with customers. We have one customer who they actually add an accurate timestamp to every Syslog event with the correct time zone in order to make sure they're normalizing their data. Because if you look at that, you look closely at your standard Syslog timestamp, at best, it's going to be hour, minute, and that's it. You're not going to have time zone. You're not going to have millisecond or microsecond.
Just before coming on here, we're working with a customer that is having issues with their Syslog. Why? No time zones in the logs.
Exactly.
No time zones at all.
I'll never forget the first time we weren't paying close attention, and I get called like Splunk's broken, and we look at it, and this time that's coming out of India is exactly 12 hours off. And it took me a minute to figure out that there was supposed to be a time zone in the event, there wasn't. And so those are the kind of things that with Cribl you have some options to manage that. And so just the UDP versus TCP have also big issues. So we're going to talk about some of the issues around the guardrails, things especially to think about with UDP Syslog. Whatever you do, do not home run your UDP Syslog data across your WAN. You're going to lose data. And make sure in this important guideline, put your destination for Syslog as close to your sources as you can. Yeah,
I can't emphasize that enough. Syslog is best over UDP, and as a result, you want to, as Ed just said, put your Cribl workers, put the collection as close to the devices as possible. So one at least in every data center, right? Or a pair of Syslog servers in every data center at the least.
Very much so. Another things for Syslog, you just really want to pay attention to how the data is formatted. Also, really work really closely with your network admins, whoever's managing these things, to try to have a standard set of configurations. If your network admins aren't paying attention, every single one of your Cisco devices can be configured differently. Have some standards. Try to have some consistency. It's super, super important. You ready to go into diagrams?
Let's do it.
So here's a standard 3-tier Syslog configuration. You got your data sources, you got your load balancer, you got Cribl nodes, and then you have a system of analysis. You have anything you want to add, and just to have this kind of a standard tiering of data?
Yeah, even though there's only one here of these icons, I can't emphasize the importance of the load balancers here.
Yes.
And the load balancer is also needing to be configured correctly. And so first of all, remember it's better to use UDP instead of TCP because you also have better load balancing generally that way. But there is also such a thing as UDP pinning, where if you have your load balancer misconfigured, even though you have 3 icons below the load balancer here reflecting 3 stream workers, the data can get funneled to one of those only if your load balancer is misconfigured and has things like sticky sessions enabled for this syslog over UDP. So always make sure that your load balancer is configured correctly, that sticky sessions are disabled, and use UDP instead of TCP where possible.
It's real important. And this is something I want to emphasize. So Stream deploys a worker process. Stream worker process is then pinned to a core. And so if you have what Ahmad's talking about, you're going to have all your traffic going to one core. So you can have 50 cores on each server, but only one core on each server is getting engaged. And so you're going to have significant limits on your ability to scale. And that's why it's so important to have a correctly configured load balancer so that you can have as much distribution across your worker processes as humanly possible. Because that's how you get that scale. That's how you can engage all the resources on the server. Because that with that pinning process, and this is where I see customers get in trouble, they've for years had all their data coming across one port. And now if you do that, your ability to distribute your data across your stream worker processes and nodes is very, very limited.
Yeah, and if you use syslog over UDP, when the data comes into Cribl, so let's pretend one of these icons right below the load balancer, Cribl, the worker is going to distribute that data across to all of the different worker processes. So if you have 16 CPUs on one of these Cribl workers, we're going to first save 2 CPUs by default for just the system to do its thing. And then we're going to spin up a different worker process mapped to each of the other CPUs. So that's 14 worker processes in that case. That load balancer, when it redirects the syslog over UDP traffic to that worker, the worker now is going to spread it across all of the available worker processes, taking advantage of all of the available CPU cores. But if you had syslog over TCP, well, load balancing in general works by TCP session. So if you have something that's just communicating over one TCP session, one TCP connection really, that is going to be routed to one Cribl worker in this case. And guess what? Just like the load balancers, the Cribl worker also will load balance based off of connections. And if all this syslog over TCP data is coming over one connection, it's going to be consumed by one core. It's going to be consumed by one core. And so we have to account for that. We have to know about that in order to have an effective syslog strategy.
I'm going to bring up a diagram now with how we want to configure your load balancers. And so this is incredibly important, is to use as many pools as you can. So what I did was I would put my checkpoints on one pool, my Cisco's in another pool, my Palos on one pool, my IBM Guardium in another pool, my generic R syslog forwarded off of whatever on a pool. Yep. Use as many pools as possible to create that ability to have as much spread as possible. So instead of a terabyte of data over one pool, you're spreading that terabyte out over 20 pools. So it's just as many as possible to get more distribution and more workers engaged.
Yeah, unless you're a small mom and pop, sending all your syslog traffic over the default 514 is a bad idea. This is where you'd want to pursue what Ed is showing here and have different pools and allocate different ports for different device types, as we have here. To simplify at the end of the day. You'll thank us when you at least do this level of planning early on.
Another thing that's really important, and this is just after hard won issues, is use your pool port, map that to that same port on your Cribl workers. Don't come up with a different port because it gets endlessly confusing after a little while. Another thing is just a tip and trick, especially dealing with TCP syslog, is I got to the point where I was creating a pool per checkpoint. So the idea that because of the pinning is so bad, you're gonna have a hard time getting distribution. So for every TCP source, I would create a separate pool for it in order to try to account for it. Also, put more workers out in order to try to give you more of a chance for scale, more cores on your syslog servers to give you more options. Because the beauty is once you get data into Cribl, it's all TCP, it's all flexible. You're going to have all those issues with managing syslog goes away, but you got to get it in there first.
Yeah, got to get it in there, and you follow these best practices, pooling, in order to have it scale out and be running well 5 years later, 10 years later, through all the different admins that you might have.
When you talk about with your F5 admins or your load balancer admins, especially at scale, talk to them about monitoring your CPU. Seen it too many times, especially with high throughput TCP, that hammers your load balancers and can cause performance problems. So this is something, just if you can, if they'll listen, have your own F5s or something like this. You start running into performance issues if you don't. Also, and as we mentioned before, do this as close to your firewalls as you can. For heaven's sake, don't home run your firewalls from one data center to another.
Yeah, so on this diagram, that load balancer, those two Cribl workers, two icons down there, those would be on a per data center at the least.
At the very least.
Maybe multiple you'll have in a data center, depending on your volume of syslog, also depending on your segmentation of your network. Right, you might have different network segments that are closed off to each other, and so you'll likely need syslog servers in each of those different segments.
Another reason also to break this up, especially if you have data governance concerns, this is where you mentioned in terms of types of data. If you need physical and logical separation, you want to do it at the work group level. I also highly recommend have two servers in your pool. Even if it's a relatively small amount of data, always have two servers. You're going to have maintenances. Your things are going to fail. You want to make sure you give yourself that ability to maintain HA.
Yeah, I always like to go with N+1. So even though I might look at a sizing calculator from Cribl and it tells me I only need one worker, always do N+1 to have that extra for high availability and for just also the unknown, where you might have a large burst of syslog all of a sudden one day, and now you at least have a scenario like that accounted for.
Exactly. Always talk to your business. What are the business resiliency requirements, so you make sure you're covered? The capacity weenies will come looking for you, wanting to know why your CPU is not getting utilized, and that way you can tell them, you got business resiliency requirements. You got to maintain your high availability. All right, so we're going to start talking about the differences between dedicated worker groups versus all-in-one worker groups. So here's an example of an all-in-one worker group. So Mike, can you kind of go through where would you use this, why would you use it, and then also why would you then break out syslog into its own worker group?
Yeah, so most customers that have one or two regions, let's say, and under a terabyte per day of data, let's say, can get away with having one all-in-one worker group where you're collecting data from various agents like Elastic. You're having data pushed to Cribl via HTTP. You're maybe using a REST collector to pull data from an API. And there's no need to overcomplicate things and separate things out. You can do it all just in one. So the reason for doing this is simplicity, and just not needing to add any extra complexity if it's not needed. Again, depending on the volume of data, I'd say primarily. And also just what are you doing with that data? Are you sending this data onto just one destination, for example, your SIM or your system of analysis? And also maybe all that data just going to go to the same object storage location. You can achieve all this for, let's say, under a terabyte per day type customer. You could go larger, but the larger you go, the more reason you'll have to start thinking of separating out worker groups into different ones.
Right. And this is why it's so important you leverage your load balancers, because if you do need to split your syslog off into its own worker group, using a load balancer makes it a lot simpler to do that. Stand up another worker group, which is incredibly easy in Cribl, and then you can update your pools in your load balancer, and you've cut over. I see this repeatedly with customers where they'll point their network devices right at a Cribl server. And that just, even though it's fast, it limits your flexibility, limits your ability to scale.
Yeah, and even though this isn't syslog related, just because it's on this diagram, and I know some people might be thinking about it, we have also on here a replay worker group in Kubernetes. It doesn't have to be in Kubernetes. Here we're just using that as an example because the typical use case with replay is you're going to run them periodically. You're not going to be running them all the time. And so the idea is, hey, Kubernetes allows you to scale up and scale down. So why not do something that's you're only going to be using every once in a while in Kubernetes? But again, it can also be in EC2 instances, on-prem VMs, and so on.
Yeah, the ephemeral nature of Kubernetes is ideal for a replay worker group. And it also helps you just evolve. One thing I see constantly is people get to this small and then they grow. They expand their utilization once they figure out how many problems Cribl can solve. And then you'll see that we have a small worker group for replay, and then all of a sudden you're using it more and more, and it grows. Your syslog grows. So you always want to put yourself in a position to handle the question of what's next.
That's right. So back to syslog. So here we're doing an all-in-one, but sometimes you'll want to have syslog in its own dedicated worker group.
So one thing I also want to call out, though, if you're really managing your data, really transforming it, lots of regex, then you also have to be careful about your all-in-one capabilities as well. And that's where because you have an automated spread, so Elastic or the UF or the HEC, going to give you the ability to have a nice even distribution. Syslog won't, and so that's why. But the first thing you want to plan on long term is pulling syslog out into its own worker group. All right, let's go to the next. So this is the idea of a larger scale where you have independent worker groups, and you can see right slap in the middle we have a dedicated worker group for syslog. And so you mentioned syslog sources, and so can you kind of describe that and where you do this, how you would do it?
Yeah, so this is where now when you're doing in Cribl commits and deploys, when you do a commit and deploy because you made a change for your syslog data processing, it's not going to affect all the other worker groups, right? Nothing else is going to stop for momentarily and continue processing. Just the syslog would be the one that now would that need to be restarted. And so you're kind of isolating the workflow there, so that again you have more continuity, less restarts, if you will, and also the more complex you're doing any of the processing for your syslog data, the more need, as Ed was saying earlier, there is to have a dedicated worker group for your syslog. That way, your CPU cores now can have more breathing room, if you will, for doing that syslog processing, separate from the processing that would be required for your other data sources.
Well said. And I think from an architectural perspective, when business resiliency, this is a good design for being able to fail small. So let's say that your firewall, you have a DDoS, or you have a massive spike of data. That spike of data is only going to impact your syslog worker group. It's not going to shut down everything else. Where in an all-in-one worker group, you have a massive spike of data that can cause your other data sources to get impacted as well. And so this is where it's in a high volume environment, in a regulated environment, where environment you have expectations of a very high SLA for availability. Splitting up your data sources gives you more options, more resiliency. Think of it as failing small instead of failing big.
Yeah, and I don't know if we want to talk about this here now, but what about having one worker group for syslog across 2 or 3 data centers?
And actually, I think so. That's a great thing to talk. Let's talk about change management. Some organizations have to do change management data center by data center. Others don't. From as an admin, you always want to find that intersection of what are my requirements and also what's going to minimize how much work I have to do. And so ideally you want to have syslog is when the same worker group across multiple data centers, because it's all going to be the same type of data, same ports. And so you make one change, you're handling 3 data centers. But be aware, sometimes you're just not going to be able to do that. And that's where you have to use multiple worker groups. But that's the joy of where you want to start looking at Cribl packs, because packs will give you the ability to apply the same configs easily across multiple data centers, so that you can try to at least make managing, having more admin overhead, at least try to minimize it as much as you can.
Yeah, amongst our peers and other customers as well. Oftentimes, we have architecture conversations, and our initial instinct is we think, oh, different data centers. That means we should have different worker groups for each data center. It's better instead to think of the worker groups based off of the technology. So for Syslog, have a worker group. For your Elastic agents, have another worker group. Maybe in a case like that, you might need multiple depending on how the data spread. But think of initially first to divide worker groups, divide them by technology first, and then perhaps might come next geographic location.
And I agree. And that's where it's just, you always, as an admin, you have to figure out what are my requirements, what's going to minimize my effort. But we give you options for both. And even if you have to have multiple worker groups for worker group per data center, at least it's significantly easier than dealing with other solutions. So most other solutions, every server every server has to be managed individually. So at least this can can at least help you manage those requirements as best as you possibly can.
Now, if I was a customer and I'm hearing here about a single worker group, single Syslog worker group across my different data centers, I likely have one destination where all this data is going, but for the analytic tool, that is. But then for putting this data in object storage, so I again separate my system of retention from my system of analytics. I might, if I'm collecting Syslog from Asia Pac, I might want to put it in an object storage in Asia Pac. If I'm collecting from EMEA, I want to put it locally there. Same for the US. So that's an example where you can still have a common worker group in that case, but then you'll use what are called output routers.
Yes,
so
the joy of the output router.
Yeah, I love output routers because
Yeah,
that's where you basically have one destination in the pipe in the routing table in Cribl to be that output router. And then the output router is where we're going to say, hey, if it's anything from EMEA, send it to the EMEA object storage. If it's anything from US, send it to the US object storage, and so on, right? So output routers have become many of our best friends here for sure over the years.
It's indispensable. All you need is to be a set of keys to help you then identify. And the nice thing, the output router, as long as the keys are there. So for example, you have some sort of metadata field that says, EMEA, and it says Syslog, then you can say, if it's EMEA and it's Syslog, it goes here. If it's EMEA and it's application data X, go here. And so you have the ability to variabilize your data and route according to those variables. And it just makes it so much easier. I was working with a prospect who's having to hard code everything. They have 50,000 universal forwarders, and they've had to hard code because they have 9 different indexer clusters. And so they had to hard code every single universal forwarder to go to each one of the indexer clusters. And it showed me that we were talking dozens of deployment servers to handle all this. And I was just like, it's just frightening how much overhead they have there. When I showed them the output router, I was like, that's it? And I was like, yep, that's it.
Yeah, it's definitely a light bulb moment when customers see it and everybody understands it.
Yeah, it's a big deal. So let's have some closing thoughts. Syslog is not going away. I've had a couple of leaders talk about, we're going cloud. Why do we need Syslog? And I was like, well, let's talk about that. And so it's not going away. Prepare for it. Use the guardrails that we've described in order to give you some options. It's critically important. Guardrails and guidelines. Think of your amount of data. Think of the amount of data you're processing, how you're processing, your data governance. And that's where, like, the types of data. And so just to help you make the right decisions. So Ahmed, do you have any closing thoughts?
I think it's important here, if we go back to these better practices of one, collect Syslog as close to the source as possible. So never go over a WAN. If you have different segments that can't, talk over one each other in a data center, you'll need different syslog environments for each one. Then second is, because again, you're close by, you can afford to use syslog over UDP. It scales better, not just with Cribl, but load balancers as well will now be able to process that data better, actually do adequate load balancing of that data. And then third, make sure your load balancers are configured correctly. Make sure sticky sessions are disabled, because that's not just a problem for syslog over TCP, where all the data will get pinned to one, not just Cribl worker, but one Cribl worker process. But you can also have UDP pinning, where the load balancer now is pinning the data to one Cribl worker. The Cribl worker will load balance across all the worker processes, but now everything's going to just that one host to do all the syslog processing. So make sure your load balancers have sticky sessions disabled and are configured properly. And then lastly is simplify your architecture. Use a single syslog worker group to start with. There are cases where you're going to need multiple. We're not saying that that's going to universal rule, but generally that's a good way to start, and then you can go from there.
Hey, that sounds awesome. This is hard-won experience, and so this is we're here to help. Please reach out, Cribl community. So it's cribl.io/community. Sign up for our 5,000 strong Slack community. We have a really nice set of sandboxes as well. That's right off the website. We're all in the Cribl community. Also, don't hesitate to reach out over social media. The YouTube comments, we very carefully respond and track those down. And so we're here to help. We want to engage, and just we want to help you make sure that learn from us. We've either seen the mistakes or made the mistakes. I've made every mistake possible, and so I think that's the only good thing I can say is I try to learn from them. And so we want to help get you started fast, because we don't want you to have to figure this out on your own.
That's right. And one last better practice that I forgot to mention is the pooling that Ed talked about as well earlier. Don't send all of your syslog to one port, the port 514 thing. Spread it out.
Yep, break it up as much as possible. Work with your admins, your load balancer admins to get this done. Even if it takes you a little bit longer, long-term success is critical to use your load balancers. And so it's just, please don't shortcut this, because if you get to a lot of volume, you're just going to run into nonstop problems. We're here to help. If you have questions, more than happy to set up individual sessions where we can go through this. We can do office hours in the community. So we're here to help. Don't let yourself have problems, because we're here to help you. Ahmed, I want to say thank you very much for your time. I really appreciate it. We're gonna have to give Eugene a hard time for missing out, and we'll do this again soon.
All right. Thanks, Ed. Thanks, everyone.
Take care, and thank you for everyone's time.
Take care.